I want to look at a program that's got a bug in it, and I want to show you how we can find that bug and fix it. This is a program that attempts to identify the primes between 0 and 5. And a prime, as you might remember, is a number which is divisible only by itself and 1. So the basic algorithm we're going to use is we're going to run an outer for loop that sends I from 0 up to 5. And then it's going to count down with the j's, and it's going to divide I by every one of the j's from I down to 2 and see if it gets a perfect division. If it gets a perfect division, it knows it's not prime. If it doesn't get any perfect divisions, then it knows it is prime, and prime stays at 1, which is how we set it up there. So let's just run our program and see how it works. And we say start without debugging. And it says 0 is prime and 1 is prime. Well, 2 is prime because it's divisible by itself and 1. 3 is prime, 4 is not, but 5 is prime. So it's not doing it right. So we have to find what's wrong with this little piece of code. One of the simplest ways of doing this is to put in a print statement that will print out the values of the variables so we can see what's happening as they're being calculated. So I'm going to say %d mod %d equals %d, and I print out I, j, and then I mod j, so I can see how they actually change. Let's run that. And now it says, okay, 0 is prime, 1 is prime, 2 mod 2 equals 0. Well, that's odd. I'm dividing 2 by itself. I know that makes it prime because it's always going to work out. 3 mod 3, 4 mod 4. So I'm dividing the number by itself. That's why they're all saying it works out perfectly, because I'm dividing it by itself, and I'm not supposed to do that. So let's look at our code. And it says I'm dividing by j, and j starts out at I, but I is the number I'm testing. I really should be saying I minus 1 so that I start one number less than that, and then I should get the right results, because now it won't be dividing by itself anymore. Let's run this and try. And it says 0 is 1 is prime, 2 is prime, 3 is prime, 4 is not prime, but 5 is prime. So that's it. That's our right answer, and we fixed it. Now we can actually comment out the print statement because we don't need it anymore. Run it, just make sure everything works. And yes, now we've got the right answer. So that's one of the ways we can do it. Another way we can do it manually is to do what we call a walkthrough. And a walkthrough is a table that looks like this. In the first column, I've got the line numbers. And every time a variable changes, I'm going to write down the line number, and then I'm tracking the important variables, I, j, and prime. Over here, separate, I'm going to write down the output that's produced. And I just ran through it for the first 4 values. I didn't do the 5th one because I was running out of time. So it starts out, and on line 6 of the program right there, it says prime equals 0. So in our walkthrough table on line 6, prime is 0. Next, here on line 8, we set I to be 0 initially. So in our walkthrough, line 8 says I to be 0. Line 10 sets prime to be 1. Line 11 sets j to be I minus 1. Now, what's the value of I? Well, we have it written right there. So we subtract 0 minus 1, and that's the value of j is minus 1. We check to see if it should go through the loop, which says it has to be greater than 1. That's definitely not greater than 1, so it doesn't go through the inner loop. And it goes around the outer loop. And line 8, it sets I to be 1 again. Then on line 10, prime becomes 1. On line 11, it sets j to be I minus 1. So 1 minus 1 is 0. That is not greater than 1, so it doesn't go through the inner loop. The outer loop goes around again, setting I to be 2. Line 10 sets prime to be 1. Line 11 sets j to be 1. That's not greater than 1, so it doesn't go through the inner loop. Now line 8 sets I to be 3. Line 10 sets j to be 1. I'm sorry, prime to be 1. Line 11 sets j to be I minus 1 or 2. Now that is greater than 1, so it goes inside the loop. It doesn't find that 3 mod 2 is 0. So it goes around the outer loop again on line 11. It decrements j to make it 1. And then it does 3 mod 1, and that is not going to change anything. So it goes around again. Now, when it's going to exit that loop this time, and this is where it starts to produce output, because it looks at the value of prime. Prime is 1. Every time it comes out of there, it's going to look and see that prime is 1, and it's going to produce one of these lines of output. So it's when it does line 16, which is the if statement. If a prime is 1 at that point, it produces the output, and we write down the output it produces. Okay, finally, we get that. We go around the outer loop. We set I to be 4. Prime becomes 1. We come in here. J is now 3. 4 mod 3 is not 0. We decrement j. 4 mod 2 is 0. That causes us to change prime to 0. Then we set j to be 1. That doesn't change anything. We come out, prime is now 0, and we don't print that 4 is prime. And then we go through the same sort of thing with 5, which is just repeating the same thing. So walkthroughs are good for helping you understand exactly how your code works. Printfs are good for giving you an idea of how the variables are changing and helping you give clues as to how the debugging is working and where your program's going wrong. So there's 2 techniques you can use to debug your programs.